Okay, which one does not belong? There is no wrong answer.
Well, I think the
I need a bag.
All right.
You think A, why?
B, C, and D are matching to the dot.
Ah, this one is like a histogram. These are all dot plots. Cool. Okay. All right. Today we're going to compare shape, center, and spread of two different data sets. We're going to compare standard deviations of two data sets as well. Okay, these are two words that you have to know, or two groups of words, two terms. Anyways, measure of center. Measure of center tells us central position of the data. Okay, so this tells us central position of the data. We typically use mean or median to describe the center. On your final, they always ask this question really weird. They say measure of center when they're talking about mean and median. Okay, this is mean and median. This is a fancy way of saying it. Measure of variability is the measure of spread. So it tells us how similar the observed values are for a data set. This is going to be range, IQR, and standard deviation. Okay, again, fancy words that they're just trying to trip you up to say the exact thing that you already know how to do. Don't mess this up. Okay, measure of center, mean and median. Measure of variability, how spread out the data is. Again, if you don't have the packet in the back on the black card, we're on page 4. Okay, so looking at this, we're going to determine the mean and the standard deviation for both and compare the measure of center and the measure of variability. Okay, yesterday or Wednesday, we talked about how we plug this into Desmos. Really quick, on this dot plot, what you want to look at is you want to look at the number of dots that you have at a certain point. So there would be 135 here. There would be 136, 137, 138. What's up? One. It's in the back on the book. Oh, you're a packet. So what we're going to do is we're going to go into Desmos and we're going to type these out. So we've got 240s, 241s, 42. We got 4. So in Desmos, go ahead and try plotting this. You're going to type mean, parentheses, and you're going to type these out with the commas in between. Okay, so when you type this in, you're going to get 44.6 something, right? And even if you like left one off, you probably are going to be right around that area, right? Okay, so taking a look at our data really quick. Can we also just kind of like find the center? Like look at this data really quick. We go from 35 to 55. Where is this mean gonna lie? Like probably right here, right? That's like the middle, right? Like right in here. We can kind of guesstimate it. We may not get it exactly, but the mean is gonna be 44.66. Now for the standard deviation, we're gonna do the exact same thing, except this time in Desmos. Say words again. Yeah, you could copy and paste all that, or I think you can type over it. Let's try find out. What do you do? What do you mean? Yeah. Panicking. All right. So standard deviation is going to be 4.8. You were so worried I was going to have to type all that junk again. All right. There you go. Okay. So what I want you to do now is I want you to do the same thing for this guy. Okay. Take a moment, plug this in. The biggest thing is making like a little mistake on forgetting a number or that kind of thing. Shouldn't be super detrimental if there's a lot of numbers though. Okay, so when I put all that in, I got 55.6-ish. I think you said that you got 56. For standard deviation, what did you get? Okay, so here is the next thing. Now we're going to compare. When you compare and contrast something, what you do is you find what is similar and then what is different. So really quick, we have this data set. We go from 35 to about 55, okay? Over here, we go from 40 to 70. Which range is going to be bigger? This one, right? So second set range is larger. And your standard deviation is larger. Okay. Now we're going to compare our mean. Our mean over here is bigger than the mean that's over here, right? Okay, so second set mean is larger than the first. And that's all you're doing. You're saying which one is bigger for the standard deviation and the mean. Huh? Compare. It's how are they different? How are they similar? Mm-hmm. Take a look at this histogram. Yay! So Lucy grows 2 different types of bean plants in her garden. Okay. She records the number of beans that she picks from each plant for 13 days. Here are the results. Okay. So this one you have to determine the mean and standard deviation. This one's going to be more like what you would see on your final. The last one had an excessive amount of numbers. This one's going to be a little bit easier to put in. Okay. So interpret the measure of center in terms of the situation, and interpret the measure of variability in the terms of the situation, and then compare the data. Okay, so over here, how do you read a histogram? Yeah.
Look at the graph, numbers on the side, how much the number at the bottom, or the duration of the top.
Okay.
So it can be different than, just go to 5 and,
Okay. So for instance, we have this little bar right here, and it goes up to 2. But it goes from, well, let's see, this is 1, right? And this is 2, and this is 2.5, and then this is 3 to 3.5. So from this, it's 2.5 to 3.5. So what is this saying? Okay, so let's read the situation again. Lucy grows 2 different types of bean plants. So here's plant A, here's plant B. She records the number of beans that she picks for 13 days. Okay, so what is this representing? Which number of beans? Okay, so she picked from 2.5 to 3.5, so 3. Okay. What's on the y-axis then? Okay. So for 2 days, she picked 3 beans. Okay, so for 2 days, she picked 3 beans, right? What about this one? So she picked 4 on what? Day 2? You see what I'm saying? Okay, so we're actually going to take this and move it to the y-axis. We're going to move this guy to the y-axis, and we're going to say that this is the days, the number of days. Okay, so on day 3, she picked 2 beans. On day 4, she picked 2 beans. On day 5, she picked 1 bean, 1 bean. On day 7, she picked 2. On day 8, she picked 1, 1. And on day 10, she picked 3. It's a weird histogram. All right, over here, on day 5, she picked 5. On day 6, she picked 1. On day 7, she picked 3. Day 8, she picked 3. Day 9, she picked 1. Yeah, it's a little bit more spread out, right? Okay, so how would we determine the mean on this side? We're looking at the number of days, right? So we're going to have what when we write out our mean? Probably 2. Okay. How many times? Okay, so on here, we're saying on day 3, we picked 2 beans, right? Yeah, but we're putting, according to what a histogram does, that means that we would have 2 3s. Okay, so 1 5, 1 6, 7. Like it's the same thing as a dot plot. It's the same thing as like a dot plot. So instead of all these bars, you would do dot dot. You see what I'm saying? So it would be 2 dots at 3. So that's why there's 2 3s. That's a little tricky. Yep. On the next one, we would find the mean on this one, and this would be 5 5s. Because what we're trying to find is the mean number of days in beans. Yeah, this is just poorly written. That's okay. So looking at this, we have a mean of 6.6 on the first one and a mean of 6.54 on the second one. And then we have a standard deviation of 2.6 and then a standard deviation of 1.45. So what's crazy is the mean on this guy is higher. Okay, so now we're going to compare. The mean on plant A is higher than B. And then let's look at the standard deviation. This is lower than plant A. So standard deviation B is lower than A. Okay, variability. So we're looking at 1980 and 2020. Okay, you don't really have to do anything with these numbers over here on the side. This is just telling you the dates. But what you're going to do is you're going to find the mean of these, find the mean of these, find the standard deviation for both, and then compare. Go ahead and take a moment. All right, so what'd you get for your mean? 54.4. All right, what'd you get for the mean for over here? 36.5.
0.8.
Okay, and then standard deviation for the first one?
5.45.
5 point.
5.6.
Okay, and then standard deviation on this one.
13.8.
Okay, so talk to me. How do I compare these? Which one has that higher mean?
1980.
Yeah. 1980 goes in.
1980 and 2020 has a higher
Standard deviation.
standard deviation.
Okay. Has yeah, that's fine. Standard deviation. Okay, really quick. So it's not gonna be like super short like this. What they're saying here is that the average temperature for 5 days in Atlanta is going to be higher in 1980 than in 2020.
So
That's how the answer would be written out. Does that make sense? They would use as many words as possible so that they can confuse you. Okay, then they would say the average temperature standard deviation for 5 days in Atlanta is higher for 2020 than it is for 1980. Okay,
So, what I'm hearing
page
is
4.
the statement is true.
Yes, statements are true. Yeah. Our statements are true, but yes, we're just comparing. Yeah, that's all we're doing. Okay, have you ever heard of a bell curve? Nobody's ever heard of a bell curve. Okay. All right. So when they talk about bell curves, they always talk about it in like grading. They're like, yeah, it was graded on a bell curve. And what that does is basically take all of your data and then find the middle and then kind of score it off of that. Okay. So right here, our middle would be here. Okay, so we got a mean of 50. Mean is always going to be in the middle. Mean is going to be represented by this X bar. Okay, the standard deviation is going to be 25.82. They just did this. You could also see this as mu for mean. Okay, so normal distribution, that's that bell-shaped curve. Okay, so it's symmetrical. Okay, so looking at this, we have the histograms below represent a group of 500 healthy people that had their temperature taken. 2 histograms represent examples of the data that approximate a normal distribution, and 2 histograms represent non-examples of that data. What do you think the elements are a definition of normal distribution? So look at the examples that are on the left-hand side and the non-examples. Yep. What is that? He said,
Upside down.
it's an upside down U. Okay, so he's saying that there's this type of shape that looks like a bell curve. Great. Michael, were you going to say anything? You got some? Did he take your answer? Oh, okay. All right, so is there anything else that you noticed? Go ahead.
The non-examples are upside down U for deformed U.
Or it's a, why you gotta call it a deformed U? Okay, yes. So this is going to be what we called skewed. Okay. And this one is also going to be called bimodal. You might see that word a little later. Okay, so again, this is going to be a bell-shaped curve. And we're going to say symmetrical as well. Symmetrical. So I used to be a baseball junkie. So my older brother used to play baseball, and he was a pitcher, and we used to run stats on him, and it was super fun. And this is where those stats come into play. So pay attention. If you're good at stats, you can make a lot of money, especially in gambling. I don't condone gambling. Okay, so imagine you are standing at the door of our classroom. How would the students enter? So if you would arrive early, then more students would come in, and finally the numbers of students decreases with a few arriving late. Not throwing shade, not throwing shade. Okay. Oh, we would have a couple come in early. Majority of the people are going to be on time, and then you're going to have a bunch that, or a few that are late, right? Okay. In our normal distribution, real world examples are going to be something like height or shoe size. What's the average shoe size of the American? What's up? Go ahead. So for girls, it's probably like 7, 8. For boys, I don't know what the y'all shoes. 10, 11, 12, somewhere in there. Okay. What about the average height of a woman? Is it really 5'4"? Man, I am a giant. Okay. What about guys? God. Okay. So IQ scores, that's also one. SAT scores. All right. SAT scores. Lifespan of light bulbs. That's another one. Kernels of corn popped. Like, think about when you put the microwave, you put your popcorn in the microwave and it starts popping, and then it pops like for like a hot second there, and then it like slowly pops. That's that normal distribution. Okay. So our requirement is going to have measures of center, which are equal. That means your mean, median, and mode are all equal. They're going to run down the middle. Okay. What is what? Okay. This right here is skewed left. The reason why it's skewed left is because this little tail is on the left-hand side. Tail is on left side. That's how you know that it's skewed left. Skewed right is going to have the tail on the right side. Okay, here's that bimodal again. Here's that bimodal. Okay, this is where the mean is going to fall in the middle and the modes are going to fall here and here. Remember, mode means most often. So with the left skewed, your median is going to fall like in that middle. It's where the highest part of the hump is. And then mean is going to fall a little left to it. For my right skewed, your median is going to be, again, near that little hump. And then mean is going to fall to the right of it. Yeah. No mode is going to just be this little box. You're not going to see this. You don't have to learn this part. Okay. But it is possible that you have no mode. That would just be consistent data. That's like if you got 100 on every assignment, that's what it would look like. Or you got, sorry, not 100 on every assignment. You got a 40, 50, 60, 70, 80, 90, 100. Yeah, that would be not so great. This is the part you want to pay attention to. This is the part that trips people up. This is also the first unit of stats for AP Stat if you take it. So pay attention because you might see it again. Okay. So here's what's going to happen. Ready? Your mean is going to go in the middle. That's that mu symbol. You're learning Greek today. Standard deviation. Each one of these is going to be a standard deviation away. So what we're going to do is we're going to write this as mu plus sigma. The next line, we're going to have mu plus 2 sigma because we are 2 standard deviations away. The last one, we're going to have mu plus 3 sigma. Okay, so see what I wrote down at the bottom. Mu's in the middle. Then we've got 1 standard deviation away. We got mu plus 1 sigma. We go 2 standard deviations away. We got mu plus 2 sigma. 3, we're going to go mu plus 3 sigma. Everybody okay on that? Nothing crazy? Do they have different signs? What do you mean? I just do like the little bars to help me remind. There's 1, there's 2, there's 3. Yeah. You just gotta memorize it. Yeah, mu equals mean. Mu kind of sounds like middle. Kind of sounds like mean. I just work here. Okay. So you could have written this like mu plus sigma plus sigma. Is that what you're saying? You're saying you could do this. Does that make sense? Yep. Yes. Now on the other side, this is below the mean. So we're going to subtract the sigmas. So we're going to say mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. So again, just like what she was saying, you could say minus sigma, minus 2 sigma, minus 3 sigma. Okay, so let me throw you some more information. You got mean right here, right? Yes. 34% of your data is going to fall within one standard deviation away. On the other side, 34% of your data is going to fall into that standard deviation. The next section, we're going to have 13.5% of our data fall in this little range. 13.5. Okay. On the next section, we're going to have 2.35%. And notice how I'm writing it on both sides. So on one side and then the other. And then the last little like blip right here is going to be 0.15. Okay, so this is going to be the foundation for the next things that we do. So you want to have this kind of memorized to the point where you're comfortable with it. Okay. No, I don't expect you to have these memorized today. Okay. The more that you write it, the easier it's going to be. All right. So there is something called the empirical rule. Okay. All this is saying is the percentages, how much data is covered in that. So the numbers that I need you to memorize with this is about 68% of the data falls within one standard deviation. About 95% is going to fall within 2 standard deviations. And then you have 99.7 that's going to fall within 3 standard deviations. How they got those numbers is they just added up that 34 plus 34 to get that 68. Then they added the 13.5 plus 34 plus 34 plus 13.5 to get 95. And then the last one, they added up all 3 of those standard deviations on both sides. What's up? So they didn't count this junk that's out here. See, it's not too bad. Y'all thought it was gonna go crazy. Yeah. That's not that bad. Can I ask a stupid question? I have had 3 teachers come in this morning. Is nobody teaching today?
No.
Who covered your class? Brooke? Westbrook. Blue hair guy? Yeah. What? Yes. No, he's a youngin.
No, when the testing, nobody was here.
All right, so go ahead and look at the last line. Go ahead and pick your favorite and come up with a scenario about it. Pick your favorite, come up with a scenario about it. It can be a short story.
Wait, what did you
I was testing upstairs.
Oh,
It was stupid.
okay.
No, they had me testing American Lit, which was dumb. Dumb. I don't want to teach English. Okay, look at the graphs and come up with a story about it. You just need one.
Person's height is 12. The average giant height is 9, 10. No, is this 5, 9, 10? That's 9 or 5.
Oh, that's 5.
Okay. The average height for a person is 5, 5, 8, or 5, 10. So 5, 10, and
Go ahead and take out your Delta math, and then if you have questions or you need help or whatever, come see me. You watch the video? Yes, you
Yeah.
may.
I got a question now. So
What?
is it B equals or B plus?
I do.
What the fuck you
Oh
mean?
no. Your ankles are horrible.
That's not even my ankle, those are my knees.
Okay. So this is gonna be M equals 2 plus B. Because it says whatever this person's name is worked 2 more hours than Brianna.
Okay,
That's what I wrote right here. 2 more hours than Brianna.
so I got this part right, great.
It should be 15 M.
15F, this is 15B.
No, because you assigned M to be the M chick.
M chick is great.
Mhm. Right? Yeah. Cool. Should be that. Should be keywords.
But now it was not count.
Yeah, every time you mess up, you gotta do like 2